In this video, we're going to be using proportions to compare similar shapes, any-sided shapes, polygons. First thing we need to think about is scale. What is scale? Scale is how we compare a size change of something. So either we increase the size or decrease the size. And then when we talk about that comparison, like how much did it increase, how much did it decrease, then we're talking about a scale and essentially a scale factor, which we'll get to. So when we're dealing with similar shapes, they are similar. And this is like a vocab word. It's not congruent, it's not the same, but we can say they're similar if two things are true. One is that corresponding angles are congruent, so the same exact measurement. And the second thing is that side lengths have to be in proportion, or their ratios have to be equal. And when we say side lengths, we mean corresponding lengths. Corresponding lengths are in proportion or proportional. There we go, proportional. So equal ratios, right? So let's talk about that. What does that mean? If I compare, let's say PQ is 20 units long. Let's say that this length over here, VW, is 35 units long. If I compare these two corresponding sides, set them up as a ratio, I would get 20 over 35. Since we need to reduce ratios, I could reduce these both by, let's see, 5, right? So 4, 7. And we'll talk about what this number means exactly in a second here, but so basically this shape here compared to this shape is this amount. It's either this shape is that amount smaller, or so this shape is that amount larger. So 35 is 4/7 bigger than 20, or 20 is 4/7 of 35. And so let's see, let's do one more little comparison here. Since we said that side lengths have to be proportional, any corresponding sides must be the same ratio. So let's say that TP was 8 and ZV here was 14. If we compare their corresponding sides, if we set that up as a ratio, we get 8 over 14. If we reduce that, then we get 4 over 7. Divide both by 2, we get 4/7. So these two sides are in proportion. These two sides are in proportion. So we know that these shapes are proportional. And if we continued to compare corresponding sides like SR to YX, then we would get the same ratio, 4/7. In order to name shapes that are similar, since we proved that these two shapes are similar, then we would name them using the points that are in the vertices, and we would just go in any order starting with the first name. So if I just start at P and go clockwise, P, Q, R, S, T, counterclockwise, excuse me. Then I would have to do the same starting over here with the corresponding angle. So P and V are corresponding, so I have to start there and then name them in the same order that I named these. So V, W, X, Y, Z. And the symbol that we would put in between them to say that they're similar in their name looks like a little tilde. And if you remember, the congruent symbol looks like that. Well, they're not equal, so we take away the equal part of it, and we just say that they're similar. So that's the similar symbol right there. Okay. And just remember that corresponding angles are congruent. So angle P, what's that congruent to? Angle V over here. One more, let's say angle S. Angle S is congruent with its corresponding angle, which is Y. So those angle measurements are always equal. Even though the shapes are a different size, the angles are the same measurement. So like I was saying, we were going to talk about the scale factor. This ratio that we had, the 4/7 ratio, oops, there we are. Since all of the corresponding sides are in the same ratio, then that is called the scale factor, and we use it as one of the ratios in proportions to solve for missing sides. We'll get back to that in a second. So a scale factor is where it's the ratio where we compare two corresponding sides. And if they are in the same ratio, any corresponding sides in the same ratio, we're allowed to say those shapes are similar. Let's see. So the way, let's make sure that we can find corresponding sides. Since we've been talking about corresponding sides, let's look at some shapes that are said to be similar and see some various ways that we can tell which sides are corresponding. So the first way is the most obvious. Look at the shapes. So these two look similar. I mean, their shape is very similar. All that's really different seems to be their size. So if it's obvious enough that you can tell that this left side is corresponding with this left side, then that's enough. And you can set up a proportion. But just to make absolutely sure, there are two other ways that we can do it. One is to compare the names. So sometimes you're told that two shapes are similar and you're told their names, and you have to come up with the image. And so if you compare names, then you can figure out that the corresponding vertices are in the same order in the names like we did earlier there. So if we named this A, B, C, D, and we said it was similar to A prime, B prime, C prime, D prime, then you would know that AB corresponded with segment AB. AB down here corresponds with segment AB. So comparing names is also helpful. And then if they give you a picture, then they should also give symbols. So the symbol markings for angles, symbols for angles, will tell you usually which sides are corresponding. So because this angle here has one arc, and over here this angle has one arc, then since they're the same angle, they must be corresponding. Over here, two arcs, they must be corresponding. So that's one way that you can tell. And if you can get all three, that's the best, obviously. So let's try and use some of that and figure out some missing parts of these two similar shapes. Let's apply all this stuff that we've been learning. First thing is always to figure out the scale factor. If you can figure out the scale factor, you can find any missing side length. But the trick is to find two corresponding sides that you're given the values for. We have to know the values of both of them to set up a ratio. So looking at this picture, which of the sides do we know? Which corresponding sides do we know values for? Well, if you look at the top, we know a value, and over here on the top we know a value. So set that up as a ratio and reduce. If we knock off the zeros, we're left with 2/3. So this shape over here is 2/3 bigger than this shape on the left here. So all of its sides must be 2/3 longer than the sides over here. So the scale factor is 2/3. and we can use that to find the missing sides. So you use this as your first ratio, set it equal to two other corresponding sides. So we know x and we know 21. Since we set our scale factor up comparing the left side to the right side, that's how we got 2 over 3. We did 20 over 30. Then all of our other ratios must be in that same order. So if we're comparing left to right, we need to also set up the next ratio comparing x over 21. And then we cross multiply, solve for x. So 3x equals 42. So x must be 14. 3 goes into 4 one time, so we'd say how many times does 3 go into 12? 4 times. So x is 14. Let's solve for z. So we do 2/3 again. 2/3. Back to that first ratio, the scale factor. And we set up a ratio for z. So we're comparing left to right. Well, 10, this AD, and this AD are the corresponding sides, so left to right would be 10 over z. And then cross multiply, 2z equals 30, so z must be 15. Okay. Again, use your scale factor. Set up the next ratio for the last missing side. So we need to find y now. So 2/3 equals, same ratio is going to equal whatever this is. So left to right, a 8 over y. 2y equals 24. And y must be 12. Alright, so the last thing, let's find some missing angles here. If you remember that corresponding angles are congruent in similar shapes, if this is a right angle over here, then the angle over here, angle A prime that corresponds there, must be the exact same measurement. So M is 90 degrees. And if we're looking for N, well, we're given angle B right here, it's 120 degrees, so B prime is corresponding, it must be the same angle measurement. So N is 120 degrees. Alright, so the last thing to do is, let's compare the perimeters here. Let's get rid of this stuff that's in my way. So if we add up all the sides of the left side, or the left shape, and compare it to adding up all the sides of the right shape, we'll compare their perimeters. So 20 and 10 give us 30, plus 14 is 44, plus 8 is 52, so that's the perimeter of ABCD. So add up all these sides. 30 and 15 is 45, plus 21 is 66, plus 12 is 78. Let's compare those two as a ratio. We want the ratio of the perimeters, so 52 over 78, say 2. Well, let's divide it in half. We get 26 and 39. Okay, well, we can reduce that more. If we divide by 13, we get 2 over 3. Okay, so the perimeter, comparing their two perimeters, ends up being the same as the scale factor. Well, it should be. Any ratio that we set up comparing any two corresponding lengths, whether it's two sides, two corresponding sides, or if we compare their perimeters, we end up getting the same scale factor, and that's true. Anything in this shape is 2/3 bigger than anything in this shape, so their perimeters must also follow that pattern. Alright, so there is a little intro into similar polygons. Any sided shapes we can follow these rules of. They got to have same angles, same corresponding angle measurements, and they got to have sides that are in proportion. Okay, these two things are how we can say that things are similar.